Okay, in this presentation we're going to look at complex numbers, but we're also going to look at the form of quadratic equations or quadratic expressions. So if alpha and beta, which is these two Greek letters here, alpha and beta, are the roots of x squared plus bx plus c equal to 0, write down in terms of b and c the values of alpha plus beta and alpha times beta. Okay, so essentially what we have to do is deduce the roots and just come up with expressions for alpha plus beta and alpha times beta. Now, as always, this is an equation that you will regularly use in mathematics, the quadratic root formula. So that is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that actually matches up pretty well already with what we have up above. I'll just bring that down again. The only difference here is that rather than having ax squared, we just have x squared. That necessarily means that a is equal to 1. So I'll just bring that back up. There we go. So essentially what we're going to do there is let a equal to 1. Okay. And there we go. Just take it from there. Okay. So essentially what we have there is two roots, so it is when we let this equal to plus and when we let it equal to minus. So alpha and beta necessarily are just using that expression there. And again, I've let a equal to 1 minus b plus the square root of b squared minus 4c over 2 and minus c minus the square root of b squared minus 4c over 2. I'm just going to pause it for a second. So there we have it there. Again, I just wrote it out there on the top of the page. So the important thing here to remember is that we're just going to add these two numbers here. Okay. So we have, now just actually watch out for this. I have it over 2 down here. So essentially what I'm adding here is minus b over 2 square root of b squared minus 4c over 2, and on this side minus b over 2 minus square root of b squared plus 4c over 2. Essentially, just be careful of that divided by 2, that denominator 2. So essentially when I add them together, the square root terms just cancel out. Okay, the square root of b squared minus 4c, that's plus here, minus here, so when we add it together, they just cancel out. So what we are left with is, we are left with b squared, minus b over 2 plus minus b over 2. Minus b over 2 plus minus b over 2, that's just add them together, we get minus b. Okay, now these are different. This is where the difference in squares formula comes in very handy when we want to multiply out this expression. So essentially what we have is just actually to use the expression, and it's essentially what we can use is the difference of squares formula just to sort of speed that up. You can do the whole thing out by longhand, but essentially if you recognize that it's the difference of squares, perfect. Okay, so it's a minus, c, let's use c and d, c plus d times c minus d, where this is one expression here, this is the other. So what we have here is minus b squared. Again, what I'm going to do actually is I'm just going to take 2 below, okay, and what I'm going to do is square that down there because we're going to square everything. So actually just c plus d times c minus d is c squared minus d squared. Okay. Sorry, I actually should have a minus sign there. Okay, that should be a minus. Okay. So essentially what we have here is minus b to be squared over 2 squared minus the square root of b squared minus 4c to be squared all over 2 squared. Okay? Difference of squares. I'm making a meal of that. Okay? So minus b squared over 2 squared, that's b squared over 4. And when we square this out, we just get b squared minus 4c. Essentially, the square root and the square cancel each other out. Okay? So what we have here is b squared minus 4c all over 4. So we left with plus this. Watch out for these two signs here that cancel out. Plus 4c over 4, that gives us c. Okay, so just to sum up, alpha plus beta equals a minus b, and C is equal to alpha times beta. Okay. So the part 2 is show that the expression 3 minus 2i is a root of this formula here. So x squared minus 2 minus I times x minus 1 minus 5i. Okay, equal to 0. And essentially what we have to do is find the other root. So essentially what we're going to do here is use that question. Okay. What I'm going to do is use the first part of this question to solve the second part. I'm going to do it in one fell swoop. So b is equal to minus 2 minus I, okay, or minus 2 plus I if you prefer, okay. And c is equal to minus 1 minus 5i, or minus 1 plus 5i if you prefer taking out the brackets. I'm using the approach suggested in the first part of the question there. So find the values of alpha plus beta. Okay, well, we actually have alpha already. We'll just assign alpha the value 3 minus 2i, and what we'll do is find beta. Okay, so from before, we know that alpha plus beta is equal to minus b. That means 3 minus 2i plus b, okay, or beta, sorry, that should be beta there, is equal to 2 minus I. That is minus b, okay? So if we just work that out, beta therefore necessarily equal to minus 1 plus I, okay? Where did I get that? I subtracted 3 minus 2i from both sides. 2 minus 3 gives us minus 1. Minus I minus 2i is minus I plus 2i. That gives us plus I there. Okay. So what I'm going to do here is just double check that does this alpha times beta give us C. So essentially what I'm going to do is multiply out my two putative roots, 3 minus 2i and minus 1 plus I. Working that out, 3 times minus 1 plus I gives us minus 3 plus 3i. Minus 2i times minus 1 plus I gives us plus 2i minus 2i squared. So just adding up all the real terms there, minus 3, and that's plus 2, okay? That will give us minus 1. 3i plus 2i gives us 5i. So that is our multiple there, and that actually is equal to C. So therefore, because we have shown that alpha plus beta is equal to minus b, and that alpha times beta is equal to c, therefore we're pretty confident that alpha and beta are roots. Just actually always remember to put in a little statement like that at the end, even something just to sort of justify your answer or state your conclusion. Okay.